Welcome back, Math 2. Today we're going to talk about zero and negative exponents. And the reason we didn't really talk about them in class, like we have done with some of the others, is because they're not quite as intuitive, they're not quite as obvious as to why they work. So let's talk first about a zero exponent. So what I mean by a zero exponent is having any number, like, I don't know, 3 with an exponent of 0, or it could be x to the 0. Okay. So remember, an exponent means whatever your base is, so 3 or x, times itself however many times are listed in the exponent. So then the question is, okay, but what does it mean to have 0 multiplying, 0 products happening? Okay. Now your initial reaction is think, well, anything to the 0 power must be 0 then, because I'm not multiplying anything. But here's the thing. In multiplication, we have something that's called the multiplicative identity. And it's basically a fancy word for what number can you multiply things by that won't change anything. So let me give you a smaller example. In addition, there's the same thing. It's an additive identity. What can you add to any number that won't change it? You can add 0. So what can you multiply everything by? 1. Multiplying anything by 1 doesn't change it. So basically what they're saying, if there's a product of nothing, I'm not multiplying anything, my answer should be 1. So that means, yes, 3 to the 0 equals 1. And 25 to the 0 equals 1. And x to the 0, no matter what x is, equals 1. Now there is one stipulation with this that is going to be very important. Let's say this was your problem to simplify. The 0 exponent in this case is only on the y. So this is the only thing that's going to become a 1. Everything else will stay. And if you think about it, if I'm multiplying all of the rest of this stuff by 1, it's really just going to become 4x squared z to the third. Right? If I have 2x to the 0, that's just going to become 2, because that x to the 0 is going to become a 1, and 2 times 1 is just 2. Okay, so anything with an exponent of 0 becomes 0. Becomes 1. Jeez. Okay. But it specifically has to have that exponent. If 0 is not attached to something, then it stays as it is. Okay. The other thing we have to talk about is negative exponents. So if I have 2 to the negative 7th, or x to the negative 1, or even if I have like a fraction where I have 1 over 5 to the negative 2nd. Okay. So negative exponents, negative powers. Again, let's talk about what an exponent is. It means that number times itself several times. Okay. When you have a negative exponent, since we're doing the opposite, what's the opposite or the inverse of multiplying? It's basically dividing. Okay. Now it doesn't mean your base divided by itself, because if I had 2 to the negative 2, whatever, doesn't mean 2 divided by 2. What it really means is 1 divided by that number however many times. So let's say I had 3 to the negative 2nd. That really means that I'm taking 1 divided by 3 divided by 3 again. Okay. It's kind of the opposite, and I'll do it in red. It's up to you if you write it. If I had 3 squared, it would be like me saying, oh, 1 times 3 times 3. We just don't bother with the 1 times because that's not going to change anything like we just talked about. So while this becomes 9 down here, up here, 1 divided by 3 is going to be 1 over 9. Okay, and then 9 and 1 over 9 Those are inverses of each other, because remember, this could also be written as like 9 over 1. Okay. So basically what happens in a negative power is that you make an inverse or a reciprocal. You're basically going to picture everything that has a negative power as a fraction, and you are going to flip whether your base is in the numerator or the denominator, because we don't want to have negative fractions. We want to try to keep them all as positive as possible. They're a lot easier to work with. I just want you to understand why a negative fraction does that. Okay, so let me give you an example. Let's bring that 2 to the negative 7th down from the top. Well, what I would want to do is actually write it as 1 over 2 to the positive 7th. So basically I have to picture that this is written over 1, and anything with a negative exponent gets sent to the denominator, or if it's already in the denominator, it will get brought up to the numerator. And then I could actually solve this, because 2 to the 7th has a solution, which I imagine is very big. Let's see, I think it's 128, but I'm going to double check with my calculator. It is 128. Okay. So that means 1 over 128. Okay. Let's say I have, let's do blue, 3x to the negative 2nd y over y to the negative 1st x. Okay. Here's what I do. Now, there's a lot of things going on here, but I want to tackle the negative exponents first. Okay, my x to the negative 2nd, y to the negative 1st are my two things with negative exponents. They are going to switch whether they're on the top or bottom, but everything else stays the same. So my 3 remains up top, my first y stays, my second y comes up. You can put that 1 there. Ooh, wow. Sorry, you can put that 1 there if you would like. And then on the bottom, I have that original x, and now I have x squared. And now I'm just going to use product rule to combine these. So remember, there are exponents of 1. So in the end, we will have 3y squared over x cubed. Okay. Let's try one example that has both. Okay. Sorry, I use a lot of 3s. I don't really know why. 3 squared x negative 1 y 0. Okay. I usually like to start with 0 exponents because I really can just eliminate them. So there's a first tip. Start with 0 if they have 0. Because remember, that basically means I'm multiplying by 1, so nothing happens. So then I have 3 squared x to the negative 1. I want to do my negative exponent next. Or if you want to simplify that 3 squared first, that's really up to you. But I have to picture this whole thing as being over 1. I'm going to send this to the denominator, and I'll have 3 squared over x. Whether or not you write the 1 is up to you. And then to really finish simplifying, I need to make this 9 over x.